Right now, the modern world is dependent on critical minerals that are made in geopolitically challenging parts of the world. Electric motors, generators, data centers are dependent on a class of minerals called rare earths to make rare earth permanent magnets. So we're developing hydrogen plasma chemistries in order to generate the sorts of things that we can't make in the US anymore. So we've got more or less a microwave off of Amazon. It's got a couple capabilities that your standard microwave doesn't. I can turn everything on, it's gonna get a little bit loud, and we can show you a plasma light up and go from there. Radify is a metallization technology company. Metallization is the process of going from metal oxide to metals.
Why exactly are you involved in this?
I have a PhD in chemistry from Princeton University and have spent the last decade in metals technology development. I've been doing high temperature chemical vapor deposition of different metal alloys onto steel. Spent the last 3.5 years at a metal additive manufacturing company, basically responsible for everything at the executive level. Well, except for finance. I didn't do finance. What you're looking at is Radify's lab. We've put together a few prototype reactors with different conditions to explore what are the conditions that are optimal for turning metal oxide powder into metals.
Can you show me?
Yeah, come on up. It might get loud. We got to turn on some pumps. I am purging this system in order to get it to the right gas. And I'm setting a pressure that's allowing me to ignite it more readily before we hit play. We've effectively taken this microwave, we've drilled a hole in it, we put a quartz tube through it, we filled that quartz tube with hydrogen gas, and we are exciting that hydrogen gas such that it turns into a plasma. The plasma then is making hydrogen radicals. Hydrogen radicals come into contact with the metal oxide powder and strip oxygen off of it. We use a pump to keep the pressure at the pressure we want it to be, and we're doing all types of things like measuring the speciation with spectroscopy. Gives us an idea of what species are actually present in the plasma, at what concentration, and we are measuring the gas atmosphere with RGA, measuring temperature, measuring pressure. The more you instrument this up and save that information, the more amenable it is to learning very quickly and even dropping on top of that machine intelligence in order to further optimize. I mean, the beautiful thing about these are $200. You can see our graveyard up there is how we've learned what are the things we need to do. Building 3 of these things, they're available overnight on Amazon. We can hack them however we want. You know, the bells and whistles machines that you want to have for better control or for more scalable volumes are the sorts of things that take half a year until you get one of those units. So we don't have the luxury of waiting around to learn at the rate that we want to learn at, so we're exploring as much of the process space as we can in this cheap iterative mode.
It does feel a lot safer than the last time I saw this.
We bootstrapped it a little bit in my garage, so I cleared off my workbench of some other projects, got my wife's blessing to put a little bit of hydrogen into our garage. Just a little bit of hydrogen. It's probably done.
All right, let's see.
And we were able to extend that work to some of the rare earths. This was actually work developed by my co-founder, Dan Bullards. He was doing this, totally different application. It was for extraterrestrial mining of lunar soils for the generation of oxygen via water. And the byproduct in his case was metal. But it turns out, same chemistry, using hydrogen radical, which is one of the most reducing things on the periodic table, is capable of stripping oxygen off of pretty much everything. And called me and said, hey, I have an idea. We talked for a couple hours, and at the end of that, I told him he has to apologize to his wife because that's a pretty good idea, and I think we're gonna have to start talking more about it.
Was it scary to quit your job and start this?
A little bit. I thought maybe I'd wanna figure out how to position myself for a smooth transition, but once you start working on something that you love to do, halfway through my first day at Founders Inc., it was clear to me that it was like, I'm gonna have to quit my job and do this full time. Your willingness to take a little bit more of a leap of faith can change.
So you said you want to get all of the metals?
Yeah, our goal is to address the periodic table. Elements like dysprosium, terbium, but what we're finding maybe a little bit serendipitously is it's not just the metals that we can address. We've accidentally made a couple of things already where we're like, oh, they're almost as valuable as some of the more expensive metals. A couple of accidents that are happy. We really do think that this is how humans should be making metal, and end of the day, we get this working at an efficient cost at scale. It will be very successful.
Hello.